Alrighty, here, ladies and gentlemen, is the very last piece of new content in your AP Calculus career. So take a second to wipe away the tears here. What we are doing is, instead of rotating our regions horizontally, so here's our region, instead of spinning it around some line here and making sort of cylindrical, circular cross sections, we're spinning it around a vertical line. Okay, so we're making washers the other way. Okay, so it's going to seem somewhat familiar from the last lesson. We're still using that washer method. Whoops. But we're going to make a very fundamental change to reflect the fact that we're rotating horizontally instead of vertically. Okay. So our basic setup is going to be similar. So we're going to still do the integral from a to b. And then pi times the big radius minus the small radius, both squared, dy now. Okay, so instead of integrating with respect to x, we're integrating with respect to y. Okay, what that means is that any of your functions must be in terms of y. And here they're given to you that way, so notice I have x isolated and x isolated, so if you're thinking those were looking a little bit weird, that's why. Okay. So what we have to do here is figure out our boundaries, and our boundaries are also y values here. So notice we have an intersection here and an intersection here. Those are going to be our limits of integration now. So we have -3 is my y value now. Notice it's not -6, -3. Y equals 1. So this is going to be the integral from -3 to 1 of pi, and then big radius minus small radius, right? Well, my big radius is now the leftmost. It's the one that's furthest away from this vertical line. So my big radius is my linear function. And it's the linear function's distance from that line, 9, right? So I'm going to say 9 minus 2y squared minus, and then my inner function, which is that parabola, 3 minus y squared. Sorry, it should be the distance that parabola is. So 9 minus 3 minus y squared. And then it's also consistent with the first one, right? We're going to square that whole thing, and then dy. After that, all of my steps are the same. Okay, so the real big change here is the bounds relating to the y values and not the x values of the intersection. And that's it. So it ends up being left or right instead of up or down, but you're still looking for the further one for your big R and the closer one for your little r. You're using the same formula, and you'll integrate the same way. So I won't solve this particular integral here. At this point, I'm hoping most of you are doing these on your calculators. The result you should get here is 629.994. Make sure you capture this example, including probably a sketch of the graph to help you set these up.